Good morning students. In today's class also we are going to see some more problems in projectile motion. Okay. If R and H represent horizontal range and maximum height of the projectile, then the angle of projection with the horizontal is. Okay. We have to find the angle of projection with horizontal. Where we are having this horizontal range and maximum height. Horizontal range is given as R. Maximum height is given as h. We have to find the theta. Okay, that is with the angle with which it is projected. Then we write the formula for r, u square by g sin 2 theta. For h, u square by 2g sin square theta. Then we get r by h as u square by g for sin 2 theta, 2 sin theta cos theta, u square by 2g sin square theta. U square by g, u square by g. Then sin theta, here sin theta, we are left with 4 cos theta by sin theta. Then we get this is, if you bring to this side, we get tan theta. Tan theta is equal to 4h by r, where theta is equal to tan inverse 4h by r. That is, we are going to find the expression for theta in terms of maximum height and horizontal range. Okay, simply we can use this formula. See the next problem. If a stone S to hit a point which is at a distance d away and at a height h above the point from where the stone starts, then what is the value of initial speed u if the stone is launched at an angle theta? A stone is launched at an angle theta here with initial velocity u. Then is to hit a point which is at a distance d. It is to hit this point which is at a distance d away and at a height above the point, above this point, it is at a height h and at a distance d away from it. Okay, then what is the value of initial speed if the stone is launched at an angle theta? If it is launched at an angle theta, we have to find what is the initial speed. Here we have to just take this u as initial speed as u. They ask us to take that one. Theta is given, y is h, that is vertical height is h, x is distance is d, x is, they ask to take it as d, then we have to find this u value. Okay, we know this one, y is equal to x tan theta minus g by 2 u square cos square theta into x square. Then substituting these values, instead of y, we substitute h, instead of x, d, then tan theta minus g by 2 u square cos square theta. We have to find u square. Writing that term here, that is bringing this term to this side, g by 2 u square cos square theta into d square equal to d tan theta minus h. Then we can bring this one to that side and that one to this denominator. Then we get 2 u square cos square theta as gd square by d tan theta minus h. Then u square is, now u square is, we bring this 2 cos square theta, that is gd square by 2 cos square theta into d tan theta minus h. Then u becomes, here bringing out this square terms, d by cos theta under root g by 2 into d tan theta minus h. This is how we can find the expression for u. Okay. See the next problem. A particle is projected from the ground with an initial speed v at an angle theta with horizontal. The average velocity of the projectile between its point of projection and highest point of the trajectory is, that is, a body is projected, we have to find the average velocity between, or average velocity between this one, point of projection and highest point of its trajectory. Okay, we take the velocity as velocity and theta is given as angle with which it is projected. Then we have to find average. That is, average velocity is just simply written as distance by time. Okay. Then if we take this diagram, this is the highest point, and we find from this diagram that distance is approximately, we can write root of h square plus x square, and time of the travel is time of flight by 2. This is time of flight is 2 p by g into sin theta, and we can write x as this time period into the horizontal component of velocity t by 2 into v cos theta, where we are going to get this t value is 2u by g into sin theta into v cos theta. That is v square 2 gets cancelled, v square by g into sin theta cos theta, and we write the value of h. It is v square by 2g sin square theta. Then we calculate this v average. It is written as root of h square. It is v square by 2g sin square theta whole square plus, okay, to bring out this one here also, for this one also we are going to write this one as v square by 2g. As we are squaring this one, we multiply with 4. That is 4 into v square by 2g sin theta cos theta whole square. Okay, this is x square, this is h square. Then we bring out this v square, this is sin theta by 2g. That is one more sin square theta is remaining here, sin square theta into here sin square theta, it goes out. Then we are going to get 4 cos square theta divided by v by g sin theta. This is by t by 2 is v by g sin theta. Then we are going to get this one, v gets cancelled, g gets cancelled. Then we are left with sin theta gets cancelled. V by 2 into root of sin square theta plus, we write this one 4 cos theta as cos square theta plus 3 cos square theta. Then sin square theta plus cos square theta becomes 1. That is 1 plus 3 cos square theta under 1. Okay, that is v by 2 into root of 1 plus 3 cos square theta. This is how we are going to calculate the average velocity, okay, between the point of projection and the highest point of the trajectory. Next problem. Two particles are projected in A with speed u at angles theta 1 and theta 2, both acute angles, okay, to the horizontal respectively. Okay, they are taken from horizontal only. If the height reached by the first particle is greater than that of the second, then we have to find which one is the correct one. Theta 1 is greater than theta 2, theta 1 is equal to theta 2, t1 is less than t2, t1 is equal to t2, where t1 and t2 are times of flight. Okay, we have to find the relation between these, either thetas or times. Okay, we are going to see how we can find that. Velocity speed u. Okay, both are having velocity, theta 1 and theta 2, both are active. h1 is greater than h2. Then we have to find the relation between either these or thetas. H is written as u square by 2g sin square theta. That is, first we relate these quantities h, t and theta. Okay, then we see the problem. Okay, the formula for h is u square by 2g sin square theta, t is 2u by g sin theta. Then substituting for value of g, as g is constant, we write this t in terms of h. That is, we can write g from this one as g is equal to u square by 2h into sin square theta. Substituting that value here, okay, for g we are going to get u square by 2h into sin square theta. Then we can write t is equal to, this becomes 4h by u into 1 by sin theta. For same value u, that is, if u is same, then we can write t1 by t2 is equal to h1 by h2. This is constant, this is constant. Then sin theta 2 by sin theta 2, or h1 by h2 is equal to t1 sin theta 1, t2 h1 by h2 is equal to t1 sin theta 1 by t2 sin theta 2. If h1 is greater than h2, then we can write t1 is greater than t2 and the sin theta 1 is greater than, we first, there is no value of t1 greater than t2, then we go for this one, sin theta 1 is greater than sin theta 2 or theta 1 is greater than theta 2. Okay, now we can have this one, that is E is the correct one. Okay, we can choose this one. Okay, A is the correct one. Okay, out of which we have to choose the correct one. Okay, here our answer is theta 1 is greater than theta 2. This is how we can first we relate this. Okay, then after that relation we apply this condition. Then we get theta 1 is greater than theta 2. Okay. See the next problem. From the top of a tower 20 meter high, a ball is thrown horizontally. If the line joining the point of projection to the point where it hits the ground makes an angle of 45 degrees with the horizontal, then the initial velocity of the ball is. Okay, it is given that the point of projection and the point where it is hitting the ground, that line is making an angle of 45 degrees. Okay, and height of the tower is given as 20 meter. We have to find the initial velocity. This theta is given as, that is initial and hitting the ground g. Okay, since theta is 45, we can simply write h is equal to or x is equal to h. Then by using this one, y is equal to gx square by 2u square. That is the equation of the path of a projectile for a body which is thrown horizontally from a certain height. Then y is equal to, here y is h and x is equal to is also h. Then we substitute these values in this equation. H is equal to gh square by 2u square. We get u square is equal to 2h by gh by 2. Then u becomes root of gh by 2. Then g into, substituting this value 20 by 2, we get root of g into 10. That is taking the value of g as 10, we get u is equal to 10 meter per second. Okay, this is how we can solve this one. Okay, it is given as this angle is 45. So this one we can write this one, and simplifying this one we get 10 meter per second. Okay.